Hi friends, welcome back. After looking at a electronic latch which was using two NAND gates, now let's just change our convention, and instead of calling this S and R, let us call that S bar, R bar, and the outputs are called Q and Q bar. So as we had seen in the previous, whenever any input is a 0, any input whenever it becomes 0, the particular output becomes a 1. So whenever this input becomes 0, this is going to be 1, and if this is 1, this 1 comes back, 1 1 will make it 0, and this 0 fed back. In spite of this not being 0 anymore, this continues to remain 1. So that's how the feedback was running. So if this is made 0, this becomes 1, and if this is made 0, this becomes 1, and this becomes 0. Only thing, both 0 were not allowed. So you just have the convention with the opposite there. So instead of saying yes, let us assume it is yes bar. That means we have yes provided here, and we have an R provided here. So if you want yes bar to be 1, we want yes to be 0. If you want R bar to be 1, we want R to be 0. So in that case, the truth table for this circuit looks something like this. When both are 0 0, that means this is 1, this is 1. When both are 1, so there is no driving force to make it compulsorily to 1 or 0. Therefore, this is going to continue with the previous state. So we are trying to say, so at any point, what is S value, what is K value, and what will be the next output, n plus 1th output. So at so let me be more specific. At nth instant, if it is 0 0, then these two are 1 1. Therefore, the output does not change, and hence it remains the old one. Qn plus 1 will be same as Qn. If S is 0, S bar is 1, and R is 1, then R bar is 0. If this is 0, then this will be 1, and if this is 1, this is 1, therefore this is going to be 0. So output is guaranteed to be 0, and after we get a 0 here, even if you make R equal to 0, this becomes 1 and 1, and this 0 ensures this 1 to continue, and this 1 guarantees a 0 here, so the output is going to be 0. Now if it is 1 0, this 1 makes a 0 here. When this is 0, this becomes a 1, and a 1 coming down, and this 0 here makes a 1 here. So 1 and 1 will confirm this to be 0, and this 0 gets back here, and hence this continues to remain 1, even if this S becomes 0 after some time. So for a short time, if this is made 1, then this is going to be 1, this is going to be 0. So set action takes place. When this is made 1 for short time, reset action takes place, and both 1 1 are not allowed, because if both are 1 1, these both will be 0 0, and both output will be 1, and hence this complement action is no longer possible. Therefore, this combination is not allowed. Done. Now the issue is when we are working with multiple when we are working with multiple digits, multiple bits, then for every bit we need such a circuit to remember what you want to save. So if you want to make this remember a zero, just reset it. It will remember a zero till you set it again. Or if you want to make this to remember a 1, then just set this, and this output is going to be 1 as long as you don't reset it. So that way you can make this to remember its past action. Done. So this is going to remember 1 bit of data, and what we are now talking of is what we are talking about a bigger system. And when you have a bigger system, you need to work with multiple bits together. And when you are working in multiple bits together, then all the bits have to be stored in separate such latches. And this all the latches should be synchronously working. That means all of them should set or reset according to the input, and they should be done in unison, in synchronism, or at the same time. So, when everything has to be done at the same time, then there is some switching, there is some gating arrangement required so that the input is allowed only when you want, not all the time. And if you can provide a gating system here, and all the gates together, if you close or open, then all these flip-flops, all the latches get their input at the same instant, and hence they can be synchronized. So for doing that, we have another circuit which is meant for gating purpose. So here we apply R, here we apply S, and because of this NAND operation, so if S is there, we get a S bar, provided there is something. So whenever this is 1, and if this is 1, this is 1, we get a 0. If this is 1 and if this is 0, we get a 1. That means whenever this is 1, so if you'll just look at the NAND operation, A, B, A, NAND, B, 0, 0, 0, 1, 1, 0, 1, 1. So this is 1, 1, 1, 0. Done. So what is it trying to say is when this is 0, we get a 1 compulsorily. If one of the input is 0, then output is 1. So when this input is 0, a 0 is applied to both the gates. Therefore, S bar is also 1, R bar is also 1. Okay, so 1 1 here means it works for no change. Next, when this becomes 1, when this is 1, then you one input is 0, then the output is 1, and if the input is 1, output is 0. So whenever this is 1, you get is complement of it. If this is 0, we get 1 1. So this is what is used to synchronize the whole circuit. So this is what we called a clocked latch. And this is famous known as a flip flop. So it has got a famous name called a flip flop. A clock latch is also called a flip flap, and this flip flop is working for just set reset action. So this whole circuitry we can represent with a simple block diagram. This is set, this is reset, and this is our clock. That's our output, that's our complemented output. So that's the block diagram representation of SR flip flop or RS flip flop, whatever you feel comfortable with. You can call it SR flip flop or RS flip flop. So that's RS flip flop. Only when you are using RS flip flop, make sure that you are not going to give both 1 1 simultaneously. So one of them is compulsorily is 0, at least one of them is 0, both of them together are never 1. So that's it you need to care about when you are working with RS flip flop. But this problem is definitely a big problem, so we want this to be avoided, and we find some means to avoid this. So we come with new models of so-called flip-flops, and that's what is the matter to be discussed in our coming sessions. So till then, take care, see you, bye.